in this session, we will basically, like the title says, we are going to be learning how Aria Automation can help with the automation deployment of TKGS or TKG cluster. We'll start first setting some basic concepts and context around vSphere workload management overall. So we'll have a small overview to take a look at the infrastructure that we're using. And then we will jump into Aria Automation and see how that out-of-the-box supervisor integration and enabling self-service for users to actually use it in provisioning supervisor namespaces, and as well provisioning the Tanzu Kubernetes grid clusters, as we mentioned. And then hopefully going in and demoing all the different concepts that we're talking about. So with the vSphere 7 and vSphere 8 with Tanzu is really considered a big release of vSphere. So it enabled a lot of IT administrators across the globe to get started with Kubernetes really quickly. So it's I personally consider it a new generation of vSphere for managing both virtual machines and containerized applications, and really the fastest path out there to Kubernetes, especially if you're an organization today that invested in vSphere or been investing in vSphere for a long time. This single streamlined solution really bridges the gap between two personas. The first one being IT operations and developers. So on one hand, is that it empowers developers with this secure self-service access to a fully compliant and conformant Kubernetes API. And on the other side, it empowers IT operators with all the visibility into Kubernetes workloads and clusters, and it allows them to manage these policies for an entire group of VMs, containers, or both with a unified platform. All licensed part of the VCF or standalone. No technical, doesn't require any technical dependency, and 100% open source aligned. On the automation side, and we've shown this slide over the video series or over the Everything Aria Automation series. Aria Automation is a multi-cloud infrastructure automation platform and has a lot of services. It enables use cases around self-service, multi-cloud governance, and having all those done with DevOps in mind. Of course, for this specific session, we'll be more talking about two main services or modules within Aria Automation, and that is the automation assembler and the automation service broker, where we actually publish our content for users to actually go to the catalog and click on the content that they need to do their day-to-day job. Before we jump in, we have now two ways of offering and building Kubernetes with Aria Automation. The first one on the left-hand side is what we're focusing on today in the session. And that is using the VMware Cloud templates and be able to curate a catalog so we can assign to projects, so the project members can actually go in, entitle them to what they need to request, and then request these services from the catalog. And these services in this context would be supervisor namespaces and TKG clusters, of course. On the other hand, and very soon, in the October release, we're going also from initial availability to general availability of the cloud consumption interface feature, which is a true DevOps user experience, another user kind of experience for true DevOps experience to build modern applications leveraging Kubernetes and Kubernetes API from a common endpoint to be able to manage your supervisor clusters and dealing with them as if you're dealing with one cluster. really a great feature. I'm super excited about this feature, and it's going to allow a lot of our customers, enterprise customers who are using supervisors globally and geographically everywhere, and be able for developers using membership and project membership and governance with everything Aria Automation provides today to be able to consume the supervisor namespaces and the services within from a common location, whether it's the UI front or the CLI front or the API front. But again, today's sessions, and I'm sure we're going to do everything Aria on CCI specifically, or Cloud Consumption Interface. Again, that's coming in the October release. But today's session is going to be focused on the curated catalog and the cloud templates and how that type of integration exists today and been there for some time now. So the self-service Kubernetes request that I want to just elevate the discussion here to show you the Aria automation and where it fits with vSphere Tanzu, and as well, I've included here at the bottom of the slide is the VMware Tanzu mission control, which is Tanzu solutions under now the Tanzu Intelligent Services, which allows you to integrate, or sorry, manage Kubernetes clusters, whether on VMware or on public cloud, at scale in a central location, from a central location, or to apply central policies, access, coda, and even deploy application packages from repos, being Helm chart or standalone packages. So the first thing is we're going to look at VMware Aria Automation and what we can do in terms of the self-service request and how that self-service request can help us deploy a supervisor namespace, and how the VI admin or the developers or the DevOps can actually, what's the user experience like for them when you're deploying a supervisor namespace. The second thing we're going to take a look at is, okay, now that we were able to deploy a supervisor namespace, what about deploying a TKG cluster? And the TKG clusters in this situation is going to be built by the placement engine or using the placement engine on existing supervisor namespace. So we will set up, for example, a supervisor namespace as maybe for development, for dev, and a supervisor namespace maybe for QA, and one supervisor namespace maybe for production. And that's where we can, with capability tags that we mentioned in a lot of our webinars previously, we can decide where to place that TKG cluster and in what supervisor namespace. So we're going to take a look at that. While doing that, we can also have the capability to add this TKG cluster to Tanzu Mission Control. And what that will do is going to automatically attach the cluster to the cluster group that I'm targeting to place this TKG. So existing cluster group, so to an existing cluster group in TMC, which allows us again to do and automate things like enforcing policies, inheriting continuous delivery, and also there's other capabilities, like for example adding the TKG cluster as well, not just the TMC for enforced policy, but also for monitoring on the Aria operation for app side. And all these things can be TMC triggered. The user or the requester of the TKG doesn't even know that it exists. It's more on the SRE side and more on the ops side for these resources. So it's controlled and governed according to the organization security standards, etc. We also be able to use another use case here where we can provision any type of Kubernetes using pipelines or extensibility as well. But this is something that is currently not out of the box, but there is the building block and the tools available with Aria Operation to build these type of pipelines or build that type of extensibility, or even use custom resources, which is backed by extensibility. And that extensibility could be Aria orchestrator workflows or Aria action-based extensibility. Awesome. So one of the things also we're going to touch on later, once hopefully we have time for that, is to just give you the art of the possible in terms of how we can deploy a TKG cluster and the application running in that TKG cluster, and how it can connect to a classic virtual machine deployed using the VMware templates, just because we can. And I'll show you how within the same template to be able to provision a virtual machine and to be able to provision a TKG cluster within the same template. All right, so I'm going on to exit the slides mode and start talking and running into or logging into the Aria Automation within this is the Aria Automation SaaS. And the first thing, first to set some baseline here, is that this is vSphere 8. So in vSphere 8, we have, of course, the workload management. And in the workload management, we can see that we have enabled vSphere Tanzu on a vSphere cluster. And that vSphere cluster is now a supervisor cluster. We have 4 hosts. It's in a running config status, and it's a running host config status there. So it's running. And then we have the IP address of the control plane node address. And that's this is the supervisor Kubernetes API, basically. So if we try to browse to this IP, that takes us to the Kubernetes CLI tools. And this is where if you want to do this on Windows, or if you want to do it on Mac, or if you want to do it on Linux, allows you to download all the CLI tool, things like kubectl and the vSphere plugin, and copy them to the appropriate folders in your path here in this. And today I'm using Ubuntu Linux, so I've downloaded those CLI to my machine. I've set it up. Also, you getting started like instructions in terms of how you can use these tools. So unzip, for example, the plugin, and then copy it to this executable search path. And then this is how you basically log in into the supervisor using the kubectl and the vSphere plugin to log in into your supervisor or your supervisor namespace, and then changing context. And we'll go all over that. The second section of this, again, if the time permits, I can show you an offline demo I did for this. But the vSphere Docker credential helper helps us to push securely and pull images from an embedded hardware registry in vSphere. So vSphere today ships with, which is changing in, I think, update 2. But today, I'm working with update 1, vSphere 8 update 1, and we still have the embedded hardware registry, which you can turn on. And that actually provisions all the pods needed to stand up your embedded hardware registry, and we can push and pull securely images to, if you don't want to use, for example, the docker.io public, but the information is here. And we'll see a lot of other places where we can get to this page during our demos today. Okay. So the second thing I want to, now that we established that the workload management is enabled, we can go and take a look at some of the namespaces. And we have some namespaces that we've created in the using the vSphere CLI, and then we'll see and take a look at supervisor namespaces that was provisioned from a VMware Cloud template by the user. What I want to establish here is that every supervisor namespace is considered a compute boundary for the user. So, and in here, you have a lot of different options to set permissions, to set what storage backend you want to use, to set capacity and usage around how much CPU, memory, and storage. And let me just minimize this. And also, the Tanzu Kubernetes Grid service, what content library it's using, how many clusters already deployed. For example, you can see there's 3. Any vSphere pods up and running. So in vSphere pods, it's a Kubernetes pod, but instead of running that Kubernetes pod in a TKG cluster, in a Kubernetes cluster, it's actually running on the Kubernetes runtime, running on the supervisor directly. So it's actually directly running on the supervisor cluster and not in like a conformant Kubernetes cluster like the one we were trying to provision today, which is TKG. And then we have the VM service, which is another great service. And this is if you want to use the KPI API, Kubernetes API to actually interact with the VM operator. And then that basically shows us, for example, how many t-shirt sizes we have available to the supervisor namespace. These t-shirt sizing would be things that you would use for the size of the master nodes and the worker nodes. So what you're doing here, you're actually setting as an admin all the different uh, um, um, building blocks for the developer and what they're allowed to use. And if you go and give them one VM class, that's all they can use. And here you can see I have 16 different VM classes available within the supervisor namespace that I can choose from. And then the content library for the image for these VM service. And this is where I can go to, for example, let's say Ubuntu and download the cloud images for, I don't know, Ubuntu 22 or Ubuntu 18, etc. All what I just described can be done in the template in Aria Automation. So before we actually do that, we have to add the cloud account, which is the vCenter, as a cloud account in Aria Automation. And if we look at our cloud account, you can see it's added, verified. It's using a cloud proxy because the Aria Automation here being a SaaS form factor, and my VCF environment is in our data center. So the cloud proxy is going to propagate and proxy the API call to the vCenter through the cloud proxy. But the most important thing here is that this is available for Kubernetes deployments. That means it detected that there is an active and licensed supervisor cluster that you can make use of. To start the integration, we usually go in and start by adding the supervisor as a managed entity into Aria Automation. Without doing that, Aria Automation would not know how to interact with the supervisor. So when you go to infrastructure under resources, there's a section called supervisors, and you can see I've already went and added my supervisor in here. Now it's considered a managed Aria Automation entity, basically. And of course, there's a few things that I can do now. I can click on it. I can see what the address, again, this is the same address we clicked on a minute ago manually, but this is the same Kubernetes CLI. This is why I was saying there's a lot of different places now within the product, and you'll see where you can get to this page really easily. Most importantly is that this is, for example, an instructor, again, in terms of how do I access the supervisor cluster. So again, I can do kubectl, vSphere login, and login into this supervisor. And I'm going to do this real quickly here. So I did create some safe shell scripts so I don't expose any passwords and things like that. So I just want to show you what is in my supervisor TMM VCF. This would be the safe one. And just so I don't have to continue typing the command every time I want to log in, I can put them in a shell script and I can execute them directly. So I have a variable where I expose my IP address or the supervisor IP address for the control plane, which is this guy. And then I can put my password here and simply log in using the kubectl login and then -- server with the URL to the supervisor IP, cluster IP, and then the username. And here we're doing insecure skipping TLS verification. So let's go ahead and actually log in real quickly. Hopefully the font size is okay for everyone. So when we log in, obviously you see all the different context. So it's just telling us that you have access to the following context. And right now, the context that we want to be on is the root or the base, and that's the IP address. So to do that, and I have an alias for kubectl, so I don't keep typing kubectl. So if I do kubeconfig use context, and then I'm basically now on this context. If I do, let's say, get nodes, I get the nodes of the supervisor cluster. You can see the 3 control plane masters. These are the virtual machine that gets created when you enable your supervisor cluster or workload management, and these are the 13, 14, and 15 here. As you upgrade the WCP service or the workload manager as new updates come up. So when you update your vCenter, there will be an update for the workload management, and then we do a roll-up update, which is a Kubernetes standard, to roll a net new control plane with a new code, and then delete the old one. So your infrastructure is not impacted, and there's no outage using. And that's what I love about Kubernetes in general. And then every host has what we call spherelet, like kubelet. So this is what we're seeing here. So every ESXi host is being the worker and the 3 VMs that we provision to create. And this is how we turn your vSphere into a vSphere cluster, into a supervisor cluster. So in here, if we actually do get namespaces, we'll see all the namespaces, and these are the supervisor namespaces that we have access to. And if we look at some of them, you can see Moad Dev, you can see Moad Production, and if we expand those, we see other, and we will get there, but you'll see other Kubernetes workloads here, like vSphere pods, which is pods directly on the supervisor, TKG cluster, and this is a TKG cluster with 3 control plane and 4 worker nodes. And also, in some situation, we have virtual machines. So where is that? Elastic Sky. So you have a virtual machine that we deploy using the VM service. So you can do everything from a command line, and we'll tackle some of these very soon. Now, back to Aria Automation. Now that we have the supervisor as a managed entity, as we mentioned, we can now go in and create Kubernetes zones. So Kubernetes zones allow us to do 2 things. We can create Kubernetes zones and have the supervisor cluster as the compute destination. This type of Kubernetes zones allows us to create supervisor namespaces targeting a capability tag. And you can see the capability tag that I have here, which is VCF-WCP, or workload domain control plane. Then I can take this Kubernetes zone and add it to the project, which I will do in a second. But before I do that, I'm going to show you the next type of Kubernetes zone that we're going to use in Aria Automation. And that's a Kubernetes zone where the destination, instead of being the supervisor cluster, and since we're creating TKG clusters, we need a destination supervisor namespace. And that's what we add here, a supervisor namespace. And I have the respected capability tag for each. So if I wanted to deploy the TKG cluster in the supervisor namespace that I'm dedicating for dev, then I would put it there, and I use the capability tag moad-dev. And if I want to put it into the production, I'll use the capability tag production. Once I create these compute boundaries now for the Kubernetes workloads, I can go to my project, and we are using the company Moad, and so we have a just a customer demo that we typically use for our customer demos. So it's called Moad. So the project name is called Moad, and just like we have created and added cloud zones to enable this project and project members to consume all the multi-cloud resources that Aria Automation is able to do today, we have a dedicated Kubernetes provisioning where we can add the Kubernetes counter of that for the Kubernetes services under the Kubernetes provisioning. So here you can see the VCF WCP and the Moad Kubernetes zone. The WCP, as we mentioned, has the supervisor as the destination, and the Kubernetes zones has the supervisor namespace as destination. And this is based on what we want to deploy. Now that we have these kind of set up, we're able to go to the design and start working and creating the templates we want. And the first one we're going to take a look at is the supervisor namespace. Now, again, goes back to my going over all the different elements of the supervisor namespace. We can control these all in the infrastructure as code that we have here. So in the Kubernetes cluster or Kubernetes elements, we drag and drop the supervisor namespace object. And then in the supervisor namespace object, we can define things like what content library we want to use or make available when somebody creates a supervisor namespace. And this is really goes back to your business use case, right? So what kind of images you want to use and or enforce for both the TKG cluster creation and the VM service. And this is why I am giving listing two different, but you can list more if you want. The first one is has the I would say, I don't want to say mandatory, but you when you set up your supervisor cluster, you have to subscribe to a known a content library that has all the different TKG cluster images. And let me just quickly go show you that. So if we go to content libraries, we can see that we have this Tanzu Kubernetes releases. And if I go and show you the settings, you'll see that I'm subscribing to specific webcontent.vmware.com. And in here, you can see all these Photon and Ubuntu uh, uh, different version of Kubernetes that we use usually when we actually deploy the TKG cluster. So that has to be there. So when VMware update that list and you have the subscription to that content library, you automatically get the all the different versions that we release. Of course, certain versions are supported with certain versions of vCenter, so there's a compatibility there. And sometimes we drop older versions when you upgrade. For example, if you upgrade your vCenter from 7 to 8, there are certain versions of TKG cluster images that are compatible with 8, but not compatible with 7. So you can see all these. So in here, so the VM service is the one that I want to make available to the supervisor namespace if the user or the developer wanted to use the VM service to provision a virtual machine using the Kubernetes API. And then the name of the supervisor namespace, which is a property mapped to an input. The input is something that the user will provide. And then the constraint is the capability tag that I mentioned. And since this is a supervisor namespace, the constraint that I want to use here is the constraint that's going to let the placement engine target the Kubernetes zone with the supervisor cluster as the destination or the compute destination, because you need a supervisor cluster to create the supervisor namespace on. And then the storage, based on what storage policy I want to make available again to the supervisor namespace, where these services are going to get created. So if you create a VM service, if you create a virtual machine using the VM service, what type of storage is going to land on, and those can be basically set up in the storage profiles within the infrastructure storage profiles. The other thing is the VM classes, and we talked about, hey, how many VM classes you can say asterisk for all if you want to deploy them all, or you can come in and actually select one by one here what image, and you can create your own, by the way. I mean, this is just what's out of the box, and this is going to control all or make what t-shirt sizing you want to make available. I can literally go in and say the only available t-shirt sizing is X small and remove the asterisk if I wanted to. That's not what I want to do. So all of them. And then limits, which is really interesting. Again, as a cloud admin or SRE, you have tons of different limits, whether it's how many secrets you can create, how many service account you can create, what is the memory request default, what is the memory limits default, etc. All these things can be explicitly enforced in the template and then shared. Create a version, share it, put it on the catalog, and when people or users request, these things are applied. Obviously, with the power of the template binding, I can control and let the user put in the count they want. I don't know if you need to do that, but here in this situation, I'm doing, hey, do you want minimum 10, maximum 50? That's what you can do in terms of the number of pod counts that I want to enforce on this supervisor namespace. Once the supervisor namespace is up and running and provisioned, and I have one here that is already created. Let's see, TKC2. Let me see what it's called. Sorry. Hosting clusters and namespaces. Heavy aim. Okay, so that's the one. So I'll just type heavy here. And once the supervisor namespace is created, it is represented for the user as a deployment. Again, depending on the project, and if the project is configured to share resources across all the project members, then all the project members will see this deployment. And here we can see, we can change the lease if there's a policy enforced. And again, we've talked about policies in previous webinar sessions and how you can apply that nice governance that Arya gives organizations to be able to say, how long are you allowed to use this resource, and how many times you can renew the lease, and if you want to put a limit on that, etc. Change the owner if I'm going on vacation or leaving the company for whatever reason. I can change my ownership of this deployment to somebody else. Edit the deployment, delete it, or do iterative updates on it. And if you click into it, we'll see the topology, which is the component, the supervisor namespace. Again, the name of the namespace, what supervisor cluster it's on. Another link to the CLI or the kubectl or the Kubernetes CLI tool page, again, from within the deployment. Most importantly, what I want to show you here is that you can take action, date to action on this. So if there's anything you want to deploy on the Kubernetes on the supervisor namespace level, I can go in and apply the YAML directly from here if I don't, let's say, have access to the command line at this moment, right? So I can do it from here, or I can delete or update the limits. You can see the limits here that was coming from the template was 10. I can increase this to 20, for example, or enforce other limits. And by the way, those two day two options are showing up here because I currently don't have any day two option policies or gating. So you can, one, control what you want to list here in terms of day two actions on this object, which is the supervisor namespace. Two, if your user does use this, do you want to gate it? Do you want to have an approval policy? Do you want the manager to approve it? And do you want finance to approve it? You can do multiple level approvals and use all the things that Aria Automation allows you to do to control, a sprawl of resources, or to make sure that users are using the resources they requested. Okay, so that was the supervisor namespace. So let's move on to the TKG cluster now provisioning. In the TKG cluster, so let's go ahead and open the template for the MOAD TKG cluster. And in here, instead of dragging the supervisor namespace, we're dragging the Kubernetes cluster element. And in here, we can see the different resources that we can set up, starting with the name, which is bound to an input that the user would basically provide the TKG cluster that they want. And then there is something called cluster plan. So let's pause here for a second and go check what cluster plan is. Cluster plans is where the cloud admin defines the characteristics of the cluster, the configuration of the Kubernetes cluster that you're deploying. So if we go and check the development cluster plan for the development, so I've created a cluster plan for the MOAD dev namespace, and I created one for the production namespace. In the development, I can control what version of Kubernetes I can use. And because and based on my vCenter version, and since it's vSphere 8 update 1, part of VCF 5.0, the latest version of Kubernetes I can get to is 124. And those images are actually pulled. So Aria Automation will do an API call for the supervisor and say, hey, what is the supported Kubernetes versions? And you can see nothing older than 1.21. And if we upgrade to the, let's say, update 2, we might lose 1.21, and we might have 1.25 or 1.26 in terms of Kubernetes. So since this is dev, I mean, it doesn't hurt. This is development environment. I don't really care. I'm going to use the latest. And in here, you can define the number of control planes, which you cannot overwrite. So here I'm saying, okay, this is dev. There's no need for you to have 3 control planes. So I'm going to limit it to 1. The size of the node, and then the storage, the backend storage where that node lives. And same thing for the workers. I can start with one, and I can later I'll show you, like in the design, we can override this as the user, and the user can select, say, hey, I need 3 workers. I am deploying a heavy application, so that's why I need workers. And then also the machine class, the t-shirt sizing for that worker node, how much memory and CPU it has, and then the backend storage. Also, the default persistent volume control or claims storage class that we want to use, and then inheriting all the PVC storage classes and all the network settings. And if you have specific needs for the configuration of the TKG cluster that you're provisioning, you can toggle those off and select a different storage class for your persistent volume claims or classes. And if you want to use different, let's say, CNI, you can specify it here. You can specify the pod network, the CIDR service, the CIDR block, all these things. If you want to use a proxy for outbound connections, etc., including also the certs. We're going to inherit everything from the supervisor cluster, but if you want to have different cluster plan for different use cases, you can do that within the cluster plan. If we go and check the production one, it's a little bit different. You can see, hey, we can't have less than 3 control planes. And maybe I enforce the workers as well, and so forth. And this is where you're not allowed to use the latest Kubernetes version. That's why I'm using the N-1, let's say, and I'm using Kubernetes 1.23 because our engineering is too busy. They haven't tested 1.24 in production. So that's that's our standards in production. So all these things allows us to set up that setup, and this is where the here, instead of enforcing the plan, which you can within the VMware Cloud template, I am giving the user the option to pick development or production depending on their needs. So if they do want a development TKG cluster and they select development, they're going to go there and it's going to select and pass the right cluster plan for the TKG cluster configuration. And then the workers here, the user also can provide an input in terms of how many workers, and using the input minimum maximums and default, I can lock the user in terms of what they can. So nobody can go and just put 100 there and provision 100 workers for a TKG cluster. And then the constraint. And these constraints are going to locate the right namespace, supervisor namespace, and place the TKG cluster on it. And so we have the second tag, which is provided here as a condition. Again, this is template condition and binding, or blueprint expressions or template expressions, where I'm saying if the input is cluster plan so-and-so, put it in this supervisor namespace. If not, and this must be a production, then you place it here. So you can play with this. You can do it. You can do something super explicit where there's no conditions, and the user does not have a choice. I'm a good SRE, so I'm going to give my user a choice, and they can pick because I trust them. They can place the TKG cluster where they want to. And then the last property we want to talk about is the TMC cluster group. Aria Automation SaaS, not on-prem, SaaS supports TMC integration. So we can set once the TMC integration is set within the same cloud services portal or CSP org, we can target specific cluster plan, and this will help us. Once the TKG cluster is up and running, we can basically place it into TMC, and TMC can enforce the policies associated with that cluster group. So the cluster group itself will have certain policy, access management, etc., that will be enforced on the TKG cluster, so we can control our TKG clusters and enforce certain standard and security boundaries around it. Like, for example, I can set up a policy that says, hey, you cannot run pods as root. You have to use a non-root account, and then or escalate privileges, or etc. There's tons of stuff that you can do with TMC if you're looking at a central way of managing Kubernetes clustered at scale. And it not just around TKG, but also public cloud, because TMC also support EKS and AKS lifecycle provisioning as well. Okay, so I've already deployed this. So we're going to go and look at an existing deployment. And this existing deployment is going to look for TKC1, which is a TKG cluster that I provisioned from the template that we were just looking at. Again, on the deployment, this is going to show up as a deployment. I can change the owner, change the lease. If there's a lease, you can see here there's no lease, so it's never expires. And if we click into the TKG cluster, we see our component in the topology, and we can see that it is in the Moad dev cluster group in TMC. So if we go to TMC, go to cluster group, and click on Moad dev, we can clearly see our TKC cluster, and it's authenticating myself again. That's a security feature. Unless I lost my VPN. Oh no, I'm good. Okay, I guess we'll get back to it. And here. Okay, let it load and finish. And then the day two actions that we can take against the TKG cluster. And here I can, again, just like the supervisor namespace, but now I can apply YAML as a day two options inside the TKG cluster, inside that on-demand Kubernetes conformant TKG Kubernetes cluster. I can also do things like scale worker nodes. So if I want to go from, sorry, I'm having performance. Here we go. If I want to increase the number of nodes on my cluster, I can go from one. Currently, we have one. So if we actually switch quickly to the vCenter, and the beauty of this is that your user don't have to go and check this in vCenter. I'm just kind of going back and forth to see if you're a cloud admin watching this, you can see the how that translate into the vCenter and the vSphere client. And you can see here's my TKC1 cluster. It's within the Moad dev supervisor namespace, and if I expand that, I can see that I have one controller, one master, and one worker node. Okay. And here you can see that my TKC1 in TMC, finally the page loaded, and it is healthy. It has the agents. It tells me what version of Kubernetes it's running, who's the provider, what is the requested and allocated memory, what is the requested allocated. And if I go into TKC, I go into much more advanced insights around the agent and the extension health, component health, worker nodes health, etc. Okay. Again, our session is not Tanzu, but I just thought I actually highlight that since Aria Automation does integrate with TMC today. Okay, so what is the next day two action? And the day two actions we can do is now if we want to scale up, which is what we can go from best effort small to any t-shirt sizing within the Moad dev supervisor namespace. Remember, we actually, as a cloud admin or VI admin, we set what t-shirt sizing available within the dev Moad, and this is what shows up. So we make the API call to the supervisor and we pull those in. And the user can go in and scale up the control plane or scale up the worker nodes. And then the last one is the Kubernetes version. And because the Kubernetes version on this is latest, we don't see any options here since this was done. If the cluster plan is changed, or let's say vCenter is changed and there's available Kubernetes versions that you can upgrade to, we can do this as a day2 action. So what will happen is, again, this is not going to create an outage or break your application, because guess what? Kubernetes does roller updates. So roll-up updates will we'll provision new nodes, we'll move things to the new nodes, and then delete the old nodes without an outage. Okay, so that was the TKG cluster. And one thing I want to actually show you is that a template that represents the application that we talked about, which I'm going to show here in the slide. And this application is that within the same template, what we're doing is we're creating a virtual machine, not using the VM service, just directly from VRA using the template and using image profiles. And so the Aria Automation will provision the VMs, will provision the TKG cluster, and then we will go in and manually install the front end pod, which we already did, and then the consumer can go in and hit the load balancer. But before I do that, I want to explain one thing, and that is what happens, how is all the networking is managed. In this situation or in this scenario, our supervisor cluster is backed by NSXT. So we're using NSXT as the networking stack when we actually activated the supervisor on the cluster. And then what happens is every time we create a supervisor namespace, we actually create and instantiate a tier 1 gateway, and we connect that gateway to the tier 0. So it can, do south-north traffic and go outside of our network, or allow our customers or users to go in through and use the services within. So when we create a TKG cluster, like TKC1 here, we create a segment and we attach that segment within the tier 1 for the namespace it's landing on. So remember, when we did the template, we said, I want to deploy this TKG cluster on this namespace. Therefore, this namespace, when it was initially provisioned by the cloud admin, it automatically creates a tier 1. So any services we actually expose on the TKG cluster is going to surface on the tier 1, and it's going to be available for users to actually interact with it. Okay. The same thing with the VM service. When you provision a VM using the VM service, okay, and the VM operator, it's going to land automatically on the VM service default network within the namespace. So we already have a segment and we already have a subnet within that supervisor and the segment that the VMs will land on. So I wanted to make sure that I cover that. Now that we did that, let's go ahead and check this new architecture of an app, for example, where in Aria Automation, you see that I have a VM. This VM is using the virtual machine cloud agnostic machine. So we went here and dragged the machine cloud agnostic, and we configured it, gave it a name, flavor in terms of the t-shirt sizing, what image to use. I'm using image ref here instead of using image profiles. And I'm using Cloud Init to set up MySQL on this VM. Right. So Cloud Init is one of the options that you can use for post provisioning. So once the VM is up and running, I could have used salt state because I have a salt stack element here attached to the VM. So I can use a salt stack and apply state files. In this specific scenario, all I'm doing with the salt stack element is that I am creating a message of the day and the prohibited access kind of message. I could have also installed MySQL using this method. So there's a lot of different ways in Aria Automation to use to do things post provisioning, whether it's extensibility, whether it's salt stack, whether it's cloud config, etc. As well, here I'm deploying grains as well, and configuration metadata that I can use for group memberships on the salt stack side or on the Aria Automation config side. If I want to do things like vulnerability scanning or remote execution, etc. It's available for me if I need to. But the interesting here is that instead of having a VM with the front end on it, I'm actually creating a TKG cluster. A TKG cluster, like we did, we defined the name of the cluster, the plan we want to use, etc. But here, and the cluster group on the TMC. But here I'm also using a new property called content, not a new property, but an extra property called content, where I'm passing what YAML manifests I want to execute when my TKG cluster is up and running and online. And because of this application, I need several things. I need a cluster role binding. So I'm creating a cluster role to say this group of the system authenticated. I want to have it use this cluster role that's going to give us VMware system privileges cluster wide. This is cluster role binding, not something that it's recommended for you to use. You probably need to use role binding instead of a cluster wide binding. But this is just for demo purposes. So I am doing that so I can I'm able to deploy um, Kubernetes workloads like deployments, replica sets, pods, etc. I'm also doing a persistent volume claim, and because I need 8 gig of read write once access mode in the this is all in the namespace default. So the default namespace, I could have created a namespace and put all the stuff in it if I wanted to. A couple of secrets for the application, like the open card password and the DB password that I'm using, and and the service. Anytime you create a service that is a load balancer service, it's going to talk to the NSXT manager and it's going to create a load balancer with an external IP on the T1. And this is why I kind of wanted to show the diagram of the NSXT, especially if the supervisor is configured with an NSXT stack. And here, what we're doing is that we're creating a load balancer for port 80 and port HTTPS port 443, and also, and that's it. Usually, I add SSH22. I guess I removed it. And then the selectors that will basically match the pods, the pod that's going to be created, which we usually, here in this situation, I could have also put the front end application here. But for demo purposes, I wanted the developer to go in, log in from the command line, and actually do that. So this is what we're going to do now. So we'll switch back to the terminal. And again, I've created I think a safe. Let's see here. Da-da-da-da. Here we go. So if I show you just a shell script that I created for quick logging that I'm going to use for TKC1, I'm going to call save. This is the syntax. So here again, I have 3 variables. One being the supervisor control plane IP that we talked about, the namespace where the TKG cluster is in, and then my account password. And then in here, I'm using, again, the vSphere plugin, so kubectl, vSphere plugin, and login with the option pointing to the server and the cluster name, and then the namespace that this cluster exists in, and then pass the username, and then supply the password with the insecure skip, TLS verify in this situation. So if we go into, let's see if I remember this. Here we go. So if I execute my TKG cluster similar to let me into the Explorer MOAD TKG cluster that we provisioned this machine from, I can check my current context, and it looks like we're in the TKG cluster context. So if I do something like get nodes, I can see all the nodes of the TKG cluster. So again, 3 masters, 4 worker nodes. If we go and check our clusters in the MOAD dev namespace and expand that, we see our 3 control planes and 4 worker nodes. What we don't see is the VM, right? So if I actually go and show you the actual deployment that went from, or you used that template to provision, this is called the new architecture. If we go in here, you can see our MySQL VM. That's the IP address of the virtual machine that Aria Automation have deployed. And this is my TKG cluster. Again, the address of the Kubernetes API of the TKG cluster. This is not the same address as the address we were talking about. The other address was directly for the supervisor control plane, but this is the API on port 6443 of the KPI server of the TKG cluster itself that we're working with here, and that's the Explorer MOAD TKG cluster. I'm showing 2 compute config here. So if you don't want as a user and say, hey, why do I have to log in every single time? Well, you don't. Because this happens to be a TMC or added to a TMC, you can download the kube config. When you click that, you see a modal of the of how to access the cluster. This is a one-time thing that you do for the first 2, where you download the TMC and the kubectl, and then you put them in your executing a path like user local bin, and then you download the kubeconfig and you use kubectl with the dash dash kubeconfig parameter, right? So we can actually do that. So right now I logged in, but I think I have the Moad. Where is it? Oh, here we go. So I could very much do this. Get all, for example, kubectl get all dash dash kubeconfig, and then use. I think this is it. Explore. You can tell. You can tell I did this for the US Explorer. TKG, and if we use that one, boom. So I I could have not logged in at all and used the kubeconfig that was generated by TMC, which includes TMC policies. If you didn't do TMC or didn't have TMC integration, this is what's going to show up. Usually the user will not see this if TMC is involved, and they'll only see the kubeconfig coming from TMC or generated by TMC. But if TMC is not in the picture, and that integration is not established, you'll get access to the cluster admin access here, the cluster admin, and you download this kubeconfig. So this is if you don't want to log in at all. So if we go in here and look at some of the stuff, I'll break this down. So let's go and say, hey, give me all the, so let me clear the screen for a second and repeat my get all. Starting from the top, we already have the pod deployed here. So if I show you the VI and the VI Moad full deployment by YAML, you can see here that we're using a deployment construct. We're using some labels for the load balancers and stuff. And if we scroll down a little bit, the image we're using here is Docker. It's saved on the Bitnami. This could have been, for example, the embedded hardware registry if we wanted to. And then we provided all the different inputs that the container is expecting. So, for example, what port, what database host we want to use. This is the virtual machine IP address that we pointed out. So if we go to MySQL, you'll see it's the same IP, 10.176, 152, 148. So, and this is what I am passing here as this is my database host and what port number it's using, and some of the OpenCard database password, which we're retrieving here from the secret that we've created, that was part of the YAML in the template, and then the load balancer for the front end, etc. Okay, so let's get out of this one, and you'll see here that my pod is running, which is part of the deployment. And in here also, you can see my load balancer service. This is the load balancer service that's going to generate, it's going to have an external IP on the T1 within the service namespace. And if we actually go in and look at this, we'll see that our application is loading an application where the front end is a Kubernetes pod and the back end is a database virtual machine running on vSphere. All right. Want to see if there's any questions before. This is all I had today for the demo. Let's see how we're doing on time. Okay, we're good on time. All right, so let's see. Facebook comment: does this automation apply for all Tanzu flavors, TKG and TKG? Great question. This is only for TKG, provisioned by TKGS, the service. Is not TKG multi-cloud. So I think there's a unified TKG now approach. And the only TKG flavor that is currently going to be available is TKG, which is provisioned by the TKG service on vSphere. LinkedIn comment: can we create zone Kubernetes cluster using Aria Automation on AKS and EKS? Negative. These is specifically for VMware or for managing Kubernetes runtimes and workloads on VMware Cloud. There's currently no integration out of the box directly, except if you're using TMC, for example. There is a lifecycle management for instantiating and deploying EKS and AKS. On the Aria automation side, you would have to use pipelines or extensibility. The building blocks are there, but the content has to be built. We'll see if there will be initiatives to at some point do support AKS and AKS and GKE to be able to provision those from Aria Automation. Okay. That's it. Before I close, I want to thank everybody who joined us. Make sure to join us for the next session on VMware Automation, Aria Automation, where we talk about creating Aria Automation templates with Vincent Riccio on October 12th. In this session, we will learn how to create and manage VMware Cloud Aria Cloud templates. Deployments begin with Cloud templates, which defines machines, applications, and services. And as we saw today, we kind of show a flavor of the VMware templates where you can deploy both. Also, the TKG and Supervisor namespaces on vSphere with Tanzu. The QR code will show you to the LinkedIn invite or event. So grab your phones and scan. And with that, for those also watching the recording, thank you for spending the time with us and watching the recording. I want to thank you very much, and we'll see you in the next one.